5, we're still using SOHCAHTOA, still using our trig, but now we're going to talk about angles of elevation and depression. These are mostly word problems. So you're going to have to draw some pictures for your word problems. That's about the only way you can get these figured out. Okay? So, first thing, a little bit of background information. An angle of elevation is where you look up from the horizontal. So let's picture, like, for this particular drawing, let's say you're a person and you're standing down at the bottom and you're looking up at something. So obviously it comes from your eyes, it doesn't come from your feet. And you look up to see like some birds or something. So then the angle of elevation would be the degrees that you look up at that particular object. Okay? And then opposite of that is angle of depression. So let's say you're standing, well, the most classic one, you're flying in a plane. Never mind my drawing. But you're flying in a plane, and the angle of depression is the angle that they have to descend at in order to land at the airport. So the angle of depression means you're looking down. The words don't necessarily mean anything. We're just going to deal with the pictures and trying to get things drawn in the right place. Alright, so the first one, it says, you sight a rock climber on a cliff at a 32-degree angle of elevation. So 32 degrees is how far you look up to see the climber on the wall of the cliff. The horizontal ground distance to the cliff is 1,000 feet. So from you to the cliff is 1,000 feet. We're going to find the line of sight distance to that rock climber. So line of sight distance means from your eyes to the rock climber. So that's the hypotenuse that we're trying to find, because we're assuming that the cliff is a right angle. Okay, so you look at this and you figure out SOHCAHTOA. The 1,000 is the adjacent, the x is the hypotenuse, so this is cosine 32. And if you're still not writing out these equations and you're still getting answers wrong, then it's time to change your thought process. Alright, so we solved this. You guys should be really good at this, right? It's 1,000 divided by whatever cosine 32 is. We get 1,179.2 feet, which should make sense because it's the hypotenuse, so it has to be longer than the other side. Okay? Every problem just like this, we're going to draw pictures like crazy, so you can't make fun of my pictures. Alright, a meteorologist measures the angle of elevation of a weather balloon as 41 degrees. So there's a balloon up in the air. Let's make it a regular balloon. And when you look up at it, you look up at 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location. So from the person to the balloon is 1,503 meters. And then to the nearest meter, how high above the ground is the balloon? So x is the opposite. The 1,503 is the hypotenuse. So this is sine. We set up our sine equation. So this is a multiplication problem. And I get 986.1. Well, it said to the nearest meter, so we'll get rid of the 0.1. 986 meters high, because the balloon's floating, so we really don't need an accurate measurement. We need whole number measurement. Alright, to approach runway 17 of the airport in Oklahoma, so we've got an airplane. We'll just draw a little airplane up here. Looks like a bird. And he's flying this way, horizontally. The pilot must begin a 3-degree descent starting from an altitude of 2,714 feet. So he's descending to the ground, a 3-degree descent. He starts from 2,714 feet above the ground. Okay, the airport altitude is 1,007 feet, so this isn't really the ground. That's sea level is down here. So this is 1,007 feet. So that's actually how high above sea level this is. So we want to know how many miles from the runway the airplane is at the start of his approach. So actually, I've got my picture labeled a little bit funny. The 2714 altitude is measured from sea level. So let's relabel this a little bit. Okay, so the 1,007 feet that's the airport is above sea level is actually included in the 2714. So you have to take 2714 minus 1,007. So the airplane is actually 1,707 feet above Oklahoma. And I want to know how many miles from the runway is the airplane at the start of his approach, from the airplane to the runway. So that's the hypotenuse. Okay, and if you remember, this 3 degrees also translates down here because those lines are parallel, so that happens that way. So we've got an opposite and a hypotenuse, so that is sine again. So sine 3 degrees, which isn't very big, equals opposite over hypotenuse. So this is the division problem. We get 32,616.2 feet because that's what all of this was measured in. But we want to know how many miles. And it just so happens that there's 5,280 feet in a mile. So we have to divide by 5,280 feet. So he starts this descent 6.2 miles away from the airport. You don't want your airplane to come in too fast. If it's coming in hot, it's going to crash. Alright, airplane pilot. Another airplane. Ooh, that one's bad. Alright, sights a life raft at a 26-degree angle of depression. So the airplane's flying this way. He looks down, sees a life raft, maybe with a little person in it that says help or something. And it's a 26-degree angle of depression. His altitude is 3 kilometers, and we don't know where he is, so we're assuming this is just above sea level. We're not going to take sea level into account this time. Okay, what is the airplane's surface distance from the raft? So surface distance is across here. And remember, if that's 26, then the 26 translates in here. We've got an opposite and an adjacent. That's tangent equals opposite over adjacent. So this is the division problem, the way we have it set up. 3 divided by 18 26. And we get 6.2 kilometers. So they're seeing a life raft 6.2 kilometers away. Alright, Miguel is up in the Statue of Liberty, and you don't want me to draw this. So here's our Statue of Liberty, and Miguel's up here. Okay? Approximately 250 feet above the ground. He sights a ship coming into New York Harbor, so he's looking out straight, and he looks down and sees a boat in the harbor and measures the angle of depression as 18 degrees. I want to find the distance from the base of the statue to the ship to the nearest foot. Okay, 18 translates down here too. This is tangent again. Opposite over adjacent. So another division problem. We get 769 feet that the boat is away from the Statue of Liberty. Okay, kind of getting this? You gotta draw a picture for this or nothing's gonna work. The world's tallest unsupported flagpole. So here's the flagpole. Is in Surrey, British Columbia. It's 282 feet tall. The shortest shadow cast by the pole during the year is 137 feet long, so that's in the wintertime. To the nearest degree, what is the angle of elevation of the sun? Well, picture in your brain, you know the sun has to be up here somewhere in order to cast a shadow like that. So you would look up to the sun, and I want to know what the angle of elevation is here. So this is opposite, adjacent, this is tangent, but when you put it in your calculator, you're going to hit second tangent. Alright, so we do second tangent to A2 divided by 137. We get 64 degrees. So the sun is almost directly overhead with this. Alright, and the last one. The Americans with Disabilities Act, this is a real act, this is something people actually have to follow, states that wheelchair ramps can have a slope no greater than 1/12. That means if you build a ramp, for every 12 feet of ramp, it can only raise 1 foot, or 12 inches up 1 foot, 1 inch, that sort of thing. We want the angle of elevation for this ramp. So that would be tangent again because we're not finding the hypotenuse. Alright, so we hit second tangent again. And we get 4.8 degrees. Something tells me you don't want it any steeper than that. It's going to be pretty steep if you do more than 4.8 degrees. Okay, draw pictures for all of this stuff.